Let's go ahead and go live.
Alrighty.
Hi, everyone. So this is a joint Wolfram Institute and me live stream, and we are looking at a new Paclet for dealing with hypergraphs. And we've had a variety of pieces of code for dealing with hypergraphs that we used for the physics project. They're in the function repository, but this is a new, better, stronger version. So let's take a look. So let's start off with the basic structure. So here, I guess the red theme is an interesting one. Is that the color you're using for all hypergraph selection?
Yeah, we do.
Okay.
You want to install the Paclet if you want to actually run the code.
Absolutely. Absolutely. Okay. Okay, so let's take a look at this hypergraph. So what does this mean? What does the 7 mean there?
It's just a vertex. It's just to show that it's a list of vertices and you can specify some new ones if it's not in the edge list.
Okay, so if I remove that and I get the pure edge list there, then I get that.
Yeah.
Okay. And this layout, the 2, 3, 4, I mean, I don't need the tag there. That's some other thing, right?
Yeah, you can also tag edges, like for graphs. That's how we do it.
I see. So because for graphs, the only way to tag an edge is with a tagged edge. Right? What is it called?
Directed edge, and this is just
I see with a directed edge with a B and a tag.
Right.
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 Yeah.
So here, okay. So these things by default are, I hope, the same way we've done it in the physics project, where these are essentially path-graphed relatrixes, so to speak. These are relations, ordered relations. Is that true?
No.
The current default, yeah.
That's probably not a good idea.
Yeah.
What's that? I'm sorry, I can't. If somebody's saying something, I can't hear you. What?
There are no other edges. They're like undirected versions of hyper edges. So not directed as for graphs. That's the default.
Just a matter of option of default.
Okay, so how do I set this to be a relation that is an ordered relation?
So that comes below where there's annotations. So
no, that's not going to cut it. That's really not a good idea. There's got to be, if there's, look, the 90% case, as far as I'm concerned, is going to be the ordered case. The unordered case, I think, is a much less interesting case.
So currently we can have this idea of the relatrix graph and specify edges. This is at the very bottom as an option to do it differently. But currently what we have, the edge symmetry, has a range of default options, but it can also be fully specified specifically for a particular given set of nodes. So it's just a matter of changing that we do the default to be.
Okay. So I really think the default needs to be, given the physics project and its story with relations, I really think that should be the default. Now, there's got to be an easy way, because we've actually got all these things like symmetric, which is that represents something symmetric in the slots. So in principle, we could have in here, we could have something which, if we wanted a symmetric edge, we could just say symmetric here.
Right.
And that would.
Yeah. So if you want to jump at the very last section for a moment, you'll see exactly.
Okay, but I'm just thinking about how we would do this in general, because what we would want to do, if indeed it's the case that it's really common, we might even want a second symbol called symmetric hypergraph, just like we have, a directed edge concept, as well as an undirected edge.
Right. I don't really think that's necessary, because the idea for graphs is that the symmetry types is only 2 because of the combinatorics of number 2.
I'm aware.
As
I
you go
know.
higher.
In this case, there can be many more cases, but the issue
Exactly.
is what are the common cases? And I think the common cases are ordered relations and fully unordered. So that's why I'm suggesting that.
Yes.
But let's keep going.
Yeah, that's just a matter of option.
Everything's I mean, okay. Plot theme, that's lovely. I like that. That's very nice. That's nice. I mean, we haven't done that with graphs, have we? Are there plot themes for graphs?
I don't think so.
No, I don't think so either, but this is a good idea and a nice idea. Okay. So this is something, so in a graph, we can do this kind of thing directly, right? Same way.
Mm-hmm.
Well, not really, I think. Well, to some degree, I think. There are some differences in how it works, I believe.
Okay. Well, let's say style 1 arrow 2 comma red. 2 arrow 1. Does that work? Yes.
Yeah, but also if there's like multi-edges, and you can't really style the individual vertex in the edge, I think.
I bet you can if you say style here. If I say style.
Yeah, if it's in the list of vertices, then yes, maybe.
Right. Style of 2 comma purple. But you can't do it in place.
Yeah.
Right?
Right.
Yeah.
Okay. So here, there's a lot going on here.
Yeah, have
Does
style.
labeled work in a graph? I didn't actually know. Does it work? If I say labeled here, 2, 1.
It works.
Oh, so it does. I should use that more often. Okay. I see. So you have to use an annotation here. Does that work in graph?
For the vertex, maybe not, but you can annotate the edge similarly how labeled and style works, I think.
Yeah, okay. Well, this is nice. I mean, I'm not convinced about this way of doing an edge symmetry.
I agree.
We'll come back to that.
Yes, I actually agree with that.
Yeah. So, I mean, I think being able to use symmetric, since we've got a bunch of primitives for doing that, that might be a way to do this. Okay, but I like this.
Yeah, we can. There's an item for this in the end anyway, so we can come back to it. Yeah.
Okay. I mean, to me, it's interesting. I mean, we don't have operations in general on things like symmetric, because that symmetric 2, 3, 4 is like a set as opposed to an ordered list.
Right. Yeah. The
Okay.
idea is to be powerful enough to cover all possible partial symmetries and all that. And
okay, let's keep going. I understand this. That's pretty nice so far.
Yes, and just my personal comment here is just to highlight that I would say that the fact that we can do this, that what we claim in this section, is, in my opinion, the thing that puts us forward from a lot of the hypergraph functionality out there.
I don't give a damn. I don't do competitive stuff. I'm just interested in what we're doing.
Just a comment for context.
I just want it to work for the things that we want to do with it. Okay. So I don't understand this at all.
So that's mixed.
Oh, that's a mess. That's a mess where you're calling out these edges and saying what to do with them. I think that's what we don't want to have to do. In other words, repeating that data, and I don't even understand what 1, 2 directed a second time could possibly mean.
Yeah,
what
I
does
agree.
that mean?
Yeah, I mean,
because
I see. That's the second 1, 2. Wowee.
Yeah.
Yeah, good luck with that. I don't think that's right. I think we should be putting symbolic wrappers around these things to indicate that.
I agree with that, actually.
Well, that's what tags are for. For graphs, in order to properly annotate multi-edges, you have to tag them.
Yes, but I don't think we should be tagging here. I think that the right way to do this is something like in here. Well, we're not going to do directed because everything's directed, but let's imagine that this one was a symmetric one.
That's, yeah.
Yeah,
to just do that?
yeah, that works. You either use some wrappers that annotate it, or you use the actual option with annotation.
Yeah, well,
Just
I
to
mean, fair enough. I mean, that's similar, I guess, to what happens with something like vertex labels in graph, where you can give a list of what vertex label to give for each vertex.
Yeah, exactly.
Exactly.
Just another annotation. You can use patterns for the edges and vertices.
Yeah, well, fair enough. Fair enough. Okay. All right, let's go on.
Yeah. So it's a non-trivial problem to actually find a canonical hypergraph for
Course.
mixed multi-hypergraphs. It's
Are
difficult.
we I mean, in a graph, we don't have a canonical. Is there a canonical graph? It's the index graph, right? If I make a random graph.
No, just canonical graph.
Yeah.
Oh, there is a canonical graph? Why have
Yeah.
I never used that?
It just doesn't work for multi or mixed edge graphs. I think it doesn't work.
Right.
So to solve this problem,
Is that just a limitation, or is there a theoretical issue with that?
I mean,
somehow I managed to make hypergraph work, but I still don't know whether it's general. It works for some examples, but it was just some heuristic hack that seems to work.
I see. So there's a theorem to be proved or not about whether it really is canonical.
Yeah.
Yeah.
I mean, as far as I can see mathematically, it is canonical. The question is also about efficiency, but that we didn't really look into that much.
Are you sure it's canonical? Because for a graph, I don't even know the definition of a canonical graph. That is, you've got to have a permutation of the vertices that makes it canonical. But
Yeah.
But what? Oh yeah, this is right. I remember this. This is some particular package that does graph canonicalization. I remember using that in the 90s.
Right. So we are relying on graph canonicalization, right, Nick? Like it's explained a bit below where you are right now.
Yeah, there are a couple of methods.
Yeah.
The one is very slow, that is like combinatoric. The one is just actually converting a hypergraph to graph and using these methods for canonicalizing graphs.
Yeah.
I
Exactly.
see.
In a way, just pulling the strength of what the language already does.
Right, but so then we presumably we have a hypergraph isomorphism function.
Right.
Yeah.
Right. Yeah.
Okay.
Well, there are a few there actually in the resource function repository that I'm using.
Right. Okay. Fair enough.
Yeah.
Including one I think Jonathan wrote, right? He has some hypergraph isomorphism algorithm. Is that right?
Yeah, but I'm using no, I'm using another one. Also, my slightly modified version of it.
Okay, fair enough. Hey, I've got another question in terms of graph rendering. This whole business about what the symmetry of an edge is.
Right.
Do we think we have any iconography for indicating that?
I would say that we want an iconography for at least 3 types. So the unordered, the ordered, sort of sequential, and the cyclic. And I think it could be as simple as representing the boundary with arrows for the ordered one, and the unordered just with a like in the picture. And the cyclic one could have some sort of circular arrow inside somehow. It's not so clear to me, but at least the two extremes, the unordered and ordered.
So I'm trying to understand. In the case of isn't it that the cyclic one just has an arrow on every edge of the membrane, right? And the relation one, the ordered relation one, has from 4 to 3 to 2, but then there's nothing from 2 to 4.
That's right.
The only difference with the cyclic one is that you close the loop, right?
Correct. That's true.
Okay, so in a sense, we can indicate cyclic. If we indicated this by, in a binary edge, obviously we just indicate it with an arrow.
Yeah.
With an n-ary edge, we indicate it on the membrane.
Yeah, and the challenge there is to render simultaneously binary edges and higher arity ones, because it will be, if you know that it's only higher arity ones, you know that the arrows indicate the order structure of the edge. And that's why, by the way, we're using this sort of spider web graphic, so that there's a gap for the binary edges to exist in between the higher arity ones.
Yeah, I quite like it. Yeah, right.
Yeah,
But I mean,
it's quite different.
so let me just understand. By the way, presumably, is there a Hypergraph 3D that does
Yes,
3D rendering?
Yeah.
there is.
Okay, so here, let me just do Hypergraph 3D just for fun.
Let's see what it does.
So,
I would
okay, a little
suggest
bit of
doing
glitching. What's that?
I would suggest doing the plot theme dark. I think it's more visible.
Well, okay, but I'm just going to comment just for Nick's benefit for implementation. There's something wrong with the spherical region thing here. Am I making sense?
What do you mean with the spherical region?
Wait, it's got a lot of empty space here that shouldn't be here.
Oh, you mean the layout, right?
Yeah, this square shouldn't be a square.
Mhm.
It should be shrink wrap more closely to this, I think. Does that make sense?
Yeah, but it's the graphics issue mostly, right? I just put the graphic primitives and whatever the automatic plot
Dark.
range.
Just dark for the theme.
Would be nice if it followed the other convention. That's okay. I mean, I don't know. I'm not. Either way.
Yeah.
I live not on the dark side, so to speak. I think, maybe we can get some help from a graphic designer to deal with the question of how we actually put the arrows on this, but this looks pretty nice. I also think that default color may not be the best one, but this is nice. And so what was the point? Okay, so I think there seems to me to be a perfectly reasonable plan for, given a symmetry here, if there is a symmetry, the symmetries that we know about are ones that are either path graphs or cycles, and those ones can be indicated with arrows.
Yeah.
More complicated symmetries.
Yeah.
Right. So if I have a symmetry where I've got a arity 4 edge, and I've got a symmetry between 4 and 6 and 3 and 5, I'm kind of out of luck here. In that case, what would be needed is to actually indicate the relatrix graph in it.
Right. That's right. That's right.
So I would have thought that would be, that seems to me to be an option that's worth having, is to indicate that relatrix graph in some, some appropriately light dotted, light gray way or something.
I think a light version of the color of the edge and sort of inscribed in it, I think it will work well.
Right. So I think we should plan on that. So we could even call that, show relatrix arrow true or false type thing.
Yeah.
Okay, let's keep going. This is lovely so far. It's really nice.
Yeah.
This
is just under the hood of the canonicalization, just for reference.
But why do we need that function two-ordered hypergraph?
Well, it's just because you have arbitrary symmetry for hyper edges, right? So you can unroll every symmetry, like permute every hyper edge to multiply them, and that's how you get ordered hyper edges.
Right. So the current implementation relies on that. If you have something that is not an ordered hypergraph, as you said, the default one, then we use the permutation generators and we generate a bunch of ordered ones with the appropriate bookkeeping, and then use this graph representation to do the canonicalization. That's the current.
Okay, but that's an internal thing. I mean, the question of turning the hypergraph into, to me, there's a function, graph to hypergraph that has various options, or hypergraph to graph. Sorry. Well, there's probably both. There's probably both graph to hypergraph and hypergraph to graph.
Yeah.
There can be multiple methods.
Yes.
Right.
Right now we just have these two specialized things. We can have more general one.
Right. So hypergraph HG, comma, and then we can have a method here.
Yeah.
I
think would be a reasonable way to do it.
Yeah.
I think there's a resource function already like this.
Good.
Yeah.
Okay. All right. Operations.
So these are two very basic, just addition and multiplication.
What's that?
Just these are just two options, two operations, addition and multiplication. The way to understand this is that if you think of the adjacency hypermatrix of the hypergraph, that's a natural thing you would do with them. So we just have them symbolically at the level of the objects as well. So it's quite straightforward.
Wow. I'm a little bit scared by that. I think it will make it's not a, we've done that for images, and boy, I've seen some weird bugs from that.
But I think, yeah, in this case, at least I don't foresee a particular danger other than, because this is very well defined at the level of adjacency matrices. So we know that it's a sane thing to do. And
well, this is not a plus at the level of adjacency matrices. This is
that's a different function. Yes, this is now implemented at the level of hypergraph objects.
No, I understand that, but it's a union of the hyperedge lists, basically.
Additive union, yes, additive union, yeah.
What do you mean by additive union? As
so
in,
you're doing union, but if you share common vertices, you just keep them.
I see. It's a join, effectively.
Yeah. So for edges, you do additively, right? So if you have several edges, you multi in the output. That's why it's not just union. It's like additive.
No, I get it, but it's like doing a join. You've got a list here of hyperedges. I mean, this thing is just you break off its head and join the lists and then put its head back on.
Yes, I mean keeping track of all the symmetry types and so on. But yes, that's it. It's very straightforward.
Okay. It's not union. It's really just a join.
Yeah, it's a union on the vertices and then a join on the edges.
Yeah.
Good point. You're right.
Yes. It's union on vertices and just
right.
join on.
What does multiplication do? Is that an intersection?
It's basically an intersection, yes. And it's multiplicative.
Wait a minute. Is it an intersection or is it?
No, intersection of vertices and multiplication and multiplicities of edges, right? So basically just keeping track of if there are edges of the same type on the same site, then it just multiplies them instead of adding them like in the previous operation.
It doesn't.
So the analog is if you take the adjacency tensor of this or hypermatrix, you would do Hadamard product of the adjacency tensors. And only Hadamard when you have the overlapping parts. So that's why you do first the intersection of the vertices, and then on top of those you do multiplication of the entries.
Can I get the adjacency matrix, by the way, here?
There's hypermatrix.
It's adjacency tensor. So for the hypergraph, it's tensor.
I know it's a tensor, right?
So it's called
Well, it's a tensor for each arity.
You can,
it's a little bit tricky
because
it's like how we define tensor is to actually add some dummy vertex so that you can differentiate between multiple arities, right?
Let's get to that. Can I give you my design input on this? What I would do for the first version of this is I would have a thing called hypergraph operation where you give it something and then you give it your hypergraphs. I would not try and overload plus and times. I think it's a mistake.
Okay.
Can't tell you exactly why, but I think it's a mistake.
Sure.
And
I would
just operation has to go after, like in the graph product. They have multiple products after you list the hyper.
So you think it should be something like hypergraph product or something? But isn't one? What are you suggesting?
No, it can be called that. It's just the argument should be after the hypergraphs. What operation are you doing?
I don't think so. It's like an apply. It will look much more natural if you say hypergraph operation, and also you could have a nice operator form. You just say hypergraph operation of
type,
plus, for example, comma, HG1, HG2.
Yeah, and it might want to take, maybe it might want to take a general list of arguments. I don't know, but yeah, for arbitrary options, right, of operations.
Right. That would be my suggestion. I think that's a more defensive design. This one.
I mean, there's graph union as a symbol. There's graph
I know. So what I would suggest is this. I would suggest initially putting something like this in, and then once one understands which operations should be symbolized, so to speak, do that.
Okay, sure. sounds good.
All right, generation enumeration,
Yeah, this is the
random hypergraph.
yeah. So what's important
Vertex.
here is the sort of what is it?
I would have
The
thought that this has to follow the same principles as random graph. So random graph, for better or worse, is because remember, in random graph, there are lots of different distributions and so on you can use. It goes like that. And I would do the same thing. I would not deviate from that. I would make this be not that, but the thing with an extra level of braces. Maybe I'm wrong.
So I want to understand what you just meant. So is that 5, 8? What is it?
Five vertices, 8 edges.
Right. So it's effectively the same structure, just that now number of edges needs to specify arities and counts, right?
I'm aware, but I'm just saying it should be in braces, not 2 arguments. That's all I'm suggesting.
Okay, sure, yeah.
Because that way, if you do that, one of the things that's nice is you can say comma 5, and you get 5 random graphs.
Okay, sure.
And that follows. That's what I would suggest.
Yeah, that sounds very good.
Okay. So, yeah, this is a good idea. I mean, I think
Yeah, that was very
what
good.
options do we have here?
Yeah, that
I
was
don't even know what options we have here. I'm not even sure. Oh, I see. Here we have this notion of graph distributions, which are future mathematics for hypergraphs, I suspect.
Yeah.
Right? I mean, we could.
That's non-trivial. Yeah. That is non-trivial mathematics for hypergraphs.
Right.
Yeah.
So, but that's what we want to. That's another reason to package these things in a single first argument, right?
Okay.
Because when we have hypergraph distributions, we can just stick the hypergraph distribution in place of that first argument. That here is just a naked, sort of naked list of vertex count and edge counts.
Right.
This is nice, but I mean, that would be. Let's think some more about that. I mean, I don't think you want to do string arguments, string options there, but maybe it's an association or something like that. I'm not sure.
So
I do think the default should be connected and simple.
I agree. I think that's the default, Nick, right? Isn't it?
I think actually not. No.
Oh, really? Okay. I thought it was.
Other way around. All of them are false. So it's just completely arbitrary hypergraph, no constraints.
Yeah. But I actually agree with that. So let's make it. So I completely agree.
Probably
Simple.
it should be. Now, honestly, this is a function we should have for graphs as well.
Well,
enumerate graphs.
This works for graphs, I guess, right?
Oh, yeah.
If you just specify binary edges, then it is graphs. So the way it works, I think.
How do I specify binary edges? I would say.
We remove the first pair that specifies 2 unary edges, right? So we just.
Right. So I just want to say 4 binary edges.
Right.
Maybe in one more list.
In one more list, yeah. Because it's a list of hypergraphs. Right.
Is that really right?
No, that's something.
Right. Okay. By the way, I mean, if we don't have it, we should have at least a WFR that does enumeric graphs. But okay, let's come back to this syntax here for a second.
Yeah.
This is saying 2 unary edges and 2 binary edges, right?
That's right. Yeah.
But that's independent of. So here I could say, here I could say 8.
Yes, and so the option there, if you put, I think, yeah, that's just random. So if you put automatic, for random I don't know, but for enumeration, if you use automatic, it's going to ignore vertex count and it's just going to keep track of edge count, which was very useful for some of the searches that we had to do. And I think if you put the number of the vertex count in brackets, I think then it considers all up to that.
Okay.
I think
that's
it's
nice.
other way around. If it's not in brackets, then it's up to that.
Okay. Yeah, right.
Right, which is the same as we're doing for permutations and various other things.
Yeah.
Right. So it's generally an edge-centric approach, which I think is right. But
Right.
yeah, you have
But
control
again, I just Felipe or somebody else or Dugan or somebody. I mean, let's make a function enumerate graphs, right, for the function repository. I think it will be useful. Make sense? Is that a yes? Is that a
Yes,
I have
that's
to
it.
repeat myself? Okay.
I'm gonna know.
The,
There is a enumerate hypergraphs already there.
that's probably this. Okay, but there needs to be an enumerate graphs.
Right.
With various, I mean, that's something I'm surprised we don't have that because we have. I mean, Eric Weinstein has a variety of things for doing stuff like that. We've got a lot of data already available. Okay, let's keep going. We're going to run out of time, unfortunately, here, but let's keep going here. Oh wow. Really? Does this actually work?
It's bitmapped. You can try it. It's like, but I don't guarantee stability for this one. It's a bit glitchy, but you can try it.
Well,
maybe it has to run again. With I have a
do I run this again?
Yeah, you can run it.
Yeah, and then you draw by clicking, and then press E for an edge. So click again for another vertex, and then E for an edge between them. And then you can click on the same vertex again and others and create. Yeah.
This is pretty cool.
You can drag
Can I
them.
move the...
You can drag them, yeah.
Wow, this is pretty space age.
And then and then you can right click on any element and you can change the properties like annotations, like labels and edge type and so on.
It's nice.
Yeah.
We have a similar thing for graph, right? But nobody ever uses it.
Mm-hmm.
You mean
This is nice.
in that iGraph package? There's some graph drawing tool. Or are you talking about something else?
No. There's a thing that got built like 20 years ago, 15 years ago.
Oh, I don't know that.
Canvas, isn't it?
No, it isn't Canvas. It's actually for drawing graphs. I mean, Charles knows all about it. You should find out from Charles about it and try and make something that is sort of, it'd be good to have graph draw and hypergraph draw be consistent. But that's nice. I mean, and certainly for hypergraphs, when one's doing expository stuff, it's clearly useful. And perhaps even more useful than for graphs, because graphs, it's sort of more obvious how to lay them out. Okay, vertex count, edge
By the way,
Yeah.
you can right click on any hypergraph and start drawing, redrawing it.
Oh yeah.
And you can just splice it back after you finished.
Yes.
If you press return, just will put it back.
Right. Sorry, what do I do here? Return?
Return. Yeah,
Return.
return to get it as an object or again. Yeah.
That's very cool.
Yeah. And that's
What is
one
show
of the
vertex
things.
degree?
But by the way, this was one of the things that I was trying to communicate that we can do with other things that we can actually visually manipulate, and that's one of the advantages of having these data structures that are more intuitively manipulable. So this is a kind of an effort to make that more tangible.
Sorry, for which well, okay, so let's
I mean, my point is just that there are times when you look at an edge list of edges and it seems quite jumbled up. But if you see the graphic, it's easier to say, oh, just I need to delete that one. Visually, it's much more clear. So you go into the
I get it. I get it.
Yeah, this is just the point. Yeah.
All right.
And this is just that those functions are there just to show the matrices, just for visual cue. That I mean, that's just you already saw this with the adjacency tensor.
Well, I mean, that's amusing.
Yeah, but that's just for a show of. I mean, it has.
I wonder if that's useful as a way to display a rank 3 tensor. I mean, just like we have matrix form here.
Mm-hmm. Maybe.
I mean, probably it should be called hypermatrix form, and I wouldn't put a capital M for the matrix. I would just say hypermatrix.
Yeah, I agree. Yeah, sounds good.
But adjacency tensor, I mean, if you use adjacency matrix on a hypergraph, you might as well get the adjacency tensor, but I agree that having a general adjacency tensor seems useful.
Right.
And this business about how you deal with different arity edges, I mean, you know, I could imagine adjacency tensor with a hypergraph here that you then have a particular, you know, you can say comma 2, and you'll just get the arity 2 edges.
Exactly. Yeah, yeah. That's virtually how it works already. It just gives you a list of those staggered by.
Oh, no, that's that's what we do with hypermetrics, right? Adjacency tensor introduces this dummy vertex so that it's a single tensor and you can still distinguish all the arities. But matrix is literally just a list of ranked tensors, right? From one to a multiple arity.
Okay, yeah.
Okay, so I mean, what's probably needed is, I mean, one thing would be, I mean, one thing I could imagine being a useful representation is arity 2, arrow adjacency matrix, arity 3, arrow tensor, arity 4, arrow whatever it is.
Well, if you do hypermatrix with a capital M, though, right, it of a hypergraph, it returns this object that has an association property. I think that's exactly what it does.
Yeah.
So we can ask association property now.
What else can I ask about it?
Well, right now, not much. It's like just list of arrays, dimensions.
But
So
those things could be asked directly of the hypergraph. So why put it in a hypermatrix and then ask it there? Because we've already got functions that say things like, you know, vertex count and so on. By the way, do you have arity functions? Is there an arity function or something? What is the analogous thing for a graph? It would be, what would it be? To get the arity of every edge, of every vertex. How do you get that for a graph?
Arity is different than degree.
Vertex degree.
Yes, okay, that's right. It's vertex degree, right? So here we
Yeah.
should be able to say vertex degree of this.
Yeah, it was in the previous section. So
Okay, but that's the number of hyperedges, but it
Yeah, yeah,
doesn't
but-
tell me the arity of the hyperedges.
yeah, the arity. Yeah, there should be one. Yes, it's just the length of the list specifying the edge.
I know, but I mean,
Yeah.
this is just saying, but so there's a separate thing, which is for an edge. I mean,
Yeah, I mean, the arity of an edge is a. This is actually a very important point, as you were saying earlier. The arity of an edge is essentially going to be the head of the head and the length of the edge, right? So
right.
it's not
So you could imagine a function edge arity.
Sure. And it would
Which,
give
if you actually gave the edge here, it's very boring because all it's doing is getting the length of the edge.
Yeah,
but
I would
edge
say
arity.
Yeah, it should give the length and the type, right?
Well, but that's a different thing. I mean, edge arity, like vertex degree, would give the list of these things, and it could have a second argument that allows you to get the types.
Sure. Yeah. Yeah. Okay. Yeah. Edge arity sounds good. And maybe then I'm thinking either call it edge arities in plural or simply arity or something like that, because if it's going to be
Can't call it
operating
arity. It's not going to. If it's ever going to be anything that integrates with the rest of the system, arity is too general.
Okay. Sure.
I mean, we're
It's
calling it
like
vertex. What's that?
It's almost like edge symmetry. We have this function that returns symmetries, right?
So edge arities.
No, but it doesn't. That's the whole point. It's not vertex degrees plural. It's vertex degree because you can give the name of a vertex here. Now, one of the differences is in these hypergraphs, you've been using 1, 2, 3.
Okay. Yes.
As the atoms, but it doesn't have to be 1, 2, 3.
Right. I get it. Yeah. I see. Yeah. This is the. the details of the rewriting stuff.
Well, but so how do you actually do a rewrite? We don't even have graph rewriting as a built-in thing, although hypergraph rewriting may be easier.
Well, here's an example, right? You just literally take two objects and apply one to another, and I get all the data related to rewriting.
Yeah. So that's the actual way that we can run it. So specifying a rule can be done also with a drawing. Like we have the rule environment for drawing. So if you do hypergraph rule, hypergraph.
Yeah, but what's the non-drawing version of that?
Hypergraph rule, which is just takes two hypergraphs as inputs and takes the first one as a. So
why is it hypergraph rule? Why isn't it just rule? Why isn't this something like hypergraph replace?
Well, there is a hypergraph apply underneath it, so that you have a rule.
Yeah. The rule has some special behavior that you basically want to make sure that there is a sub hypergraph common to both that is essentially preserved in the rewrite process, and so what has to appear on the right hand side has some bearing on what happened on the left hand side. So that's why this is a special thing, like hypergraph rule, more than just some general replace or transformation, which is also there, but this is sort of more higher level for specifically hypergraph writing as is typically done.
I don't understand. What aspect of it is not specified by variable names? See what I'm saying? There's a matching of variable names in any replacement rule. What aspect of that is not done in a hypergraph rewrite rule? I mean, in the physics project stuff, I did a bunch of these where all it is you've got, I mean, for example, the creation of a new vertex. I mean, you can specify it as, X blank, Y blank, comma, whatever it is, Y blank, Z blank goes to, and then it's a new hyper edge. Go ahead.
Yeah, I do a module to create a new one.
Yes, you have to do a module to create a new name, which you also have to do here, presumably.
Yeah.
Yeah. That happens.
So, I mean, I agree that I think this requires a bit more thought. I mean, in other words, if you want the hyper edge, this is, module W or something. This goes to whatever it is, X, Y, Z, ZW, let's say.
Mm-hmm.
And that looks like that. And every time we use it, it will be different. And you're going to need some mechanism like that, right?
Well, it exists, yes. Yes. We turn, essentially, hypergraph rewriting turns into some usual rewriting. You turn it into a rule with maybe some complicated patterns with labels and symmetries, and then just use some multi-replacement. And then you just package all of them into these associations.
Yes.
It's quite lovely. I mean, I think, probably there's a bunch of grinding to do here. Let's just take a quick look here. And
yeah, these are just some applications.
Okay.
So this is what I mentioned, having something with heads. Like, I mean, obviously those names are probably better to just be like bear or bag or cycle and symmetric and so on. So simple names. And then, yeah, it's interesting that it's connected to multi-computation Paclet, that it knows about the structure of hypergraphs and how to read the causal graphs and the connections and so on.
Wow. That's really useful.
Yeah, that's super useful. Yeah.
Wow. This is really looking very good. I mean, I think there's more work to be done on that. I think one can grind down. I mean, there's some details we talked about. Maybe we should continue this at a different time.
Yep.
But I thought we were doing this at this time in the middle of the day so a bunch of other people could attend.
Yeah, let's get those people involved next time.
Yeah, but I mean, otherwise we can do these. We should be doing these Institute live streams outside of my normal day job times.
Yes.
But this is really nice. It's very well done.
Thanks. Yeah,
Good work.
we're happy with it. Yeah.
The I think it'd be nice to get a little bit of time from graphic design.
hmm
We can contribute something there, and yeah, this is very cool. I mean, I'd like to understand more about how we're really specifying these rules. Is
Yeah.
there, in fact, a specification of the rule that goes beyond the specification? Nick?
Yeah, we also have special treatment of labels. Like for example,
Yes.
for vertices, it matters whether you label the left-hand side of the rule or not.
Yeah.
Right, things like that.
Yeah.
You
I
can
It's
also
basically-
use patterns. You can use patterns for labels so that you can use, in addition to hypergraph rewriting, you can use usual rewriting so that if you have a pattern on the left-hand side as a label and you have use that symbol in the right-hand side, then it's also gonna
But I
propagate.
mean, why isn't the thing I wrote that's doing it? I mean, it's not carrying along metadata labels, but it is specifying, the names of nodes.
Yeah, well, it's close.
Yeah.
Yeah,
Yeah.
it's very
yeah.
close. But in addition, there's some label
Yeah.
problems.
What
there.
kind?
Yeah.
What-
Let me just the example I think is easier to understand is when you want to have hypergraphs as the carriers of your data, so as generalized parities. So instead of lists
Yes.
having hypergraphs, so sometimes you want ID distinct edges and nodes, but you want the same labels repeated over them. So you need to distinguish these two levels of the actual elements and the labels on top. And
All right.
and you want to do pattern matching on those, and that's where it has to be a little more tricky. That's where we added the label layer for pattern matching, essentially.
Color me mildly unconvinced. I understand what you're doing. You're pattern matching on the label, on the actual names of things.
Right.
Which
No, not names, labels. You have the separate thing.
no, I
Yeah.
understand. But you're pattern matching on the on metadata, basically.
Yes.
Which
Yeah,
is
so-
something that we haven't seen. I mean, graph replace or vertex replace certainly doesn't do that.
No, but I think it's very analogous to what you can do with pattern matching with, say, lists and expressions in general, right? Like where you can have positions, symbolic positions in these data structures, and you really want to keep track of, for example, having a list that is XXX, and you want X to be the same throughout. So you need a way to tell those apart at the pure hypergraph level, where you're thinking your hypergraph to be sort of like the be-all data structure in that framework, right? So that's the reason. I'm open to the fact that it might be that under the hood that is not necessary, that we do everything at that level. But for all the implementations that we did, this was very important to like do all the rewritings. For example, in the infrageometry stuff where you had like vectors and neighborhoods and all that stuff together, like it was very important to label those for the rules to apply correctly and only move the things.
All right. I'm not totally convinced. I mean, I can't untangle it right this second, but I suspect there's a slightly cleaner way to do it. I mean, this here is an amazing, I mean, this is something we obviously don't even have by default for the standard pattern matcher, and it's interesting.
Yeah, that's
all right.
great.
We should wrap this up now. Let's continue this either, I mean, I really was hoping we would have some other folks here. Did Ian make it here or not?
No.
This was
It
really a
didn't.
mess up. I mean, we should, yeah. All right. Anyway, we'll continue this probably outside of normal time. Maybe next Monday. We could do some more because that's a company holiday. And all right, sounds good. But this is really nice. Very nice work. Good
Thanks, Dave.
stuff. All right. See y'all soon.
See you
All
soon.
right.
Bye.